To do this is to just go like 2/3 times 125 minus 1 minus 1/2 times 25 minus 1. Who's with me?
Yeah.
Plus 3 times 5 minus 1. And now you just do this. And when you just do this, like, what do you get?
Well, that's like 248. Yep.
Really?
Yeah.
Yeah. That is 248 over 3. And that is minus
It's like 12.
24 over 2, so minus 12, and that is plus 12. Boom. Answer, 248 over 3. So, no more Riemann sums required, as long as you know an antiderivative. So for example, this was the class where like 2 classes ago, people watching home on video, I didn't do this in your period probably, unless you are also in 4th period. But remember how we tried to come up with the area under the sine curve, yeah?
Wait, we are in 4th.
I know, sorry, that was confusing. It made sense to me.
It made sense.
The goal, 2 classes ago or something, we found the area under the function fx equals sine x, yeah? People watching at home who are not in period 4, you will have no idea what I'm talking about, because I only did this mini lesson in period 4. Does that make sense now?
Wait, but we're all in period 4.
Oh my god.
They're like people watching
People
here and
watching on
stuff.
the video. Good.
Oh, right.
Good. Wait, it's been a long day. It's been lots of. Wait. Look again. Back on track. So, how did we do this? Do you recall?
Calculator.
Yeah, we like cheated basically. Like we didn't really do it. What we did was we.
That's why I just
Staying with me. What we did was we split this interval up into subintervals. Say yes.
Yes.
Then we did like 10 subintervals or something, right? And then I just like estimated. And I estimated by just like doing like letting n be 10 and getting like 1.95 and just being like, I bet that's 2. That's pretty much what happened, yeah?
Yeah.
And it was even like a double cheat because I didn't only use the calculator. This is like a little bit philosophically subtle, but I didn't only use the calculator to like make my work easier. I like used the calculator like fundamentally because I don't know how to compute like sine of pi over 10 or something.
Now you
You guys kind of with me on this?
Yeah.
I used like my calculator's ability to like take the sine of anything also. Okay, so that was like hard, and what we got was that the area under one hump of sine was like 2, right? That was our conclusion.
Yeah.
With fundamental theorem of calculus, all theorems are possible.
Any
It
system.
doesn't just let us solve problems that we already know how to do more efficiently. It means I can integrate anything as long as, and this is a big condition, I know an antiderivative of the function that I'm trying to integrate. Do you know an antiderivative of the sine
I
function?
do.
Oh yeah.
Negative cosine.
Which part of 2, right?
Negative cosine.
The part.
So we apply the fundamental theorem of calculus to say that the integral from 0 to pi of sine is just some antiderivative of sine. By the way, that's not the only possible antiderivative, but all other antiderivatives will differ by a constant, and so it doesn't matter. Evaluated at pi and 0. Whoa. Just freaking do it. What is the value of negative cosine at pi?
Well,
It's like
1.
negative cosine of pi, which is
Negative 1.
-1, minus, you gotta be really careful with your
1.
negatives, minus
Negative
the
1.
value of negative cosine at 0,
Well,
which
that's
is
negative 1.
-1. And what you get is,
2.
Negative 2.
holy crap.
Dude.
Blow the horns. And stop. Good.
Wait, it would be like the
So, good. I knew you were going to do something. something like that. Alright, so then you had this little worksheet for homework, right? Which was finding the integral from a to b of x squared. And like, dude, if you actually did this, then what you're supposed to do is, you know, x is now talking b minus a over n, and we get the picture, we got the a, and we got the her, we got the and what you end up with is like, this is like, oh my god, it's like, oh man, it's an approach to the sum from I equals 1 to n of f of a plus, don't do that, b minus a over n times I times b minus a over n, is that what you had? That's like pretty much like right, yeah?
Yeah.
Okay, now, if you plug this into the squared function, and then you have all these letters, and it's like an algebra challenge, level 7 algebra problem, all this math happens, and when you're all done, what you end up with is, hopefully, if you multiplied everything out and got common denominators and stuff like that, you end up with this.
Yep.
Woo!
Magic.
But of course, that's just obvious now in retrospect, because what is the most iconic antiderivative of x cubed, of x squared? It's just 1/3 x cubed. And so the answer to this problem is just 1/3 x cubed evaluated at b and a. Answer, b cubed minus a cubed over 3. Whoa! And perhaps even, like, maybe even like somehow deeper or something way of thinking about this is to just like know like facts about quadratics. The like fact about the y equals x squared function is that, well, you tell me, what is the area of this shape?
1/3.
It's
This
like 1/3 of the
1/3, right?
integral.
Yes, so step 1, no, but I'm with you, right?
Yeah.
Step 1, the integral from 0 to 1 of x squared is just 1/3. Fact, say fact.
Fact.
Okay, thus,
We like talked about it before.
we did talk about it before, right? So when someone wants the integral from a to b of x squared, what you might as well do is just like, that's a, that's b. Am I doing this right? Yeah, because now, you're just like, wait. Yeah. So now, this is like this or something. Shop. Okay, so now, like, what is, if this is a, then what's the height here?
It's like a
Squared.
yeah.
Right? And if this is b, then what's this height?
B squared.
B squared. Okay, so what is the area of this rectangle here?
Well, it's like a
A squared A.
The area of this rectangle is an a wide and a squared high.
A cubed.
So this has area a cubed. And what is the area of this giant green rectangle?
Well, it's like b cubed.
Oh my god.
It's like b cubed because it's b long and b squared. I've never done this before.
To scale.
So now, using like the fundamental principle of like that a parabola is 1/3 man, then what is the area of this little red crap?
It's like 1/3 of that.
It's like 1/3 of a cubed. And what's the area of this? About to ruin my picture. But all this like brown stuff here,
It's like 1/3 b cubed.
it's like 1/3 b cubed.
But you don't want.
But we don't want the 1/3 A cubed part.
What we want is the area under this curve from A to B. So it's sort of just like obviously 1/3 b cubed minus 1/3 a cubed, right? This is like thinking about geometry. All right, cool? Woo! FTC, it was like gonna be way more ambitious to do many other things, but maybe that's okay. Have you appreciated your FTC day?
Yeah.
Woo! Good. Passion is important. I think we went really slow, but maybe in a good way. Hard to
Yeah,
say.
good way.
Any other parting thoughts?
You're like.
On Friday, you guys should come to class.
I will.
When is your AP exam?
11:30.
After this.
After this.
11:30. Why?
Good. So, let me turn this off. Everyone say goodbye.
Bye.